Hey and welcome to Nerds Out of Water. I'm Michael Lobb and I'm one of the co-hosts of Nerds Out of Water. This is a technology podcast. We talk a lot about technology and this episode is no exception. We're talking today to Slater Victoroff, who's the founder and CTO of Indico, which is an enterprise AI solution for unstructured content that emphasizes document understanding, which he'll explain throughout the podcast. He's been doing this he's been building these machine learning solutions for startups, governments, Fortune 100 companies, and he's a frequent speaker at AI conferences. Indico recently announced a $22 million Series B fundraising effort. He's really interesting in terms of writing. He's an author. He's a martial artist. He's a fantastic educator, and he talks about tech with so much knowledge and understanding. Join me in welcoming Slater. Good morning, good afternoon. Slater, how are you?
Yeah, I'm doing wonderfully, Michael. How about yourself?
I'm great. It's a little bit cold here in the Gold Coast. What about you? You're in Minnesota, is that right?
I'm in Minnesota right now, and I have to say it is lovely and warm. That we got a spot of rain this morning.
Oh, nice. Yeah,
lovely and warm.
We're in the middle of winter, so it's...
I see.
Well, it was
single digits in Celsius. So I don't know what it is in Fahrenheit at the moment.
3.6 degrees at the moment outside. 3.6.
Got it. I mean, I will say I kind of like weather like that. I'm from Boston, so that's, maybe more typical for us. But, I've been out to Minnesota now. I think this is my fourth or fifth time. But the first 3 or 4 times I went during winter. Oh, and it is absolutely freezing, right? I mean, it's much nicer in the summer.
Yeah. Yeah. I'm from New Zealand, so, Queensland temperatures are great.
Oh, yeah.
Do you want to tell us a bit about yourself and your journey and how you got to where you are today? Because you've done a lot of things and you do a lot of things, so it's really difficult to understand how you got to all these places.
Frankly, Michael, if I understood myself how I got here, then I'd be doing something very different, I'm sure. So I mean, look, when it came to Indico, right? I'd love to sit here and tell you that me and my friends sat down in a dorm room and plotted out our course the next decade, and we've been executing against it, but nothing could be further from the truth, right? I think that for me, when I showed up at school, even I had not written a line of code. I had actually never even owned my own computer until I showed up in university. Wow. And I thought I was going to be a chemical engineer, in fact, right? So that's how far off this path I was. But there was something about picking up a 2-pound piece of metal, right, holding a laptop in your hand, and once you really understand the power of what you can accomplish with code, this idea that I could build empires, right, with this 2-pound piece of metal, limited by nothing but my mind and my imagination, that was something really, really special, and it just absolutely bit me. And so, I found that, pretty early after starting undergrad, and for the next, 2.5 years, I coded an average of 12 hours a day.
Wow. That's a good bit of coding. That's a big...
I was very, very lucky. My school let me basically twist all of my coursework around it. So, whatever I was doing, I found a way to make it, a technical coding project. And like you do, right? When you're a young kid starting out in programming, you find AI pretty quickly, and I was lucky enough to be pretty good at it, right? And then me and my friend just started doing Kaggle competitions together, and before we knew it, folks were asking us to help them with different projects. We sort of realized that we didn't realize that we were any good until we started competing against other folks, and that that actually started to give us a bit of the confidence to really take ourselves seriously. And it was a short hop from there to Indico, and I would say that the initial goal for us, right, was I was totally convinced in the promise of deep learning, right? In 2012, I hated it. I said to one of my professors, the war is over, deep learning lost. But, by the time 2013 came around, Alec Bradford, who was my co-founder, he had thoroughly convinced me that it was the path. And so we asked ourselves this question of, this is an incredible technology, right? We've really turned the corner on a lot of things that had been unsolved grand challenges for the space for decades and decades and decades. But even though there was this academic success, what we found is that there was a huge gulf between these academic results and something that could actually be practically adopted in the industry, something that could be used by ordinary developers. And that goal, right, crossing that bridge and making this technology accessible, that was really the goal of Indico. Never planned to drop out. I did eventually drop out, but only because we successfully raised a $3 million seed round. So
yeah.
Like thank you. No, what is it?
That paragraph you just said then, I've got so many questions around it. First of all, I just love the fact that you said, you know what it's like with young kids. You go to school and you play with AI. Well, both Michael and I have spoken about this. When I went to school, there were no computers. So I had to learn. After I left school, I learned. And I can remember at university, we had 6 computers. And my very first bit of code was the design to One-Arm Bandit.
Wow! Look at that! Oh, that's still relevant today.
It is, isn't it?
Yeah, I remember the first AI program I ever made was a genetic algorithm to you gave it a number and it would give you an equation that got you pretty close. So you give it 4, it tells you 2 plus 2. And that was the most magical thing in the world to me at the time.
Well done.
A reverse calculator.
What were you coding in? When you started, right at the beginning.
Yeah. So, embarrassingly enough, I started in MATLAB, which I would argue is not really a programming language. I was in MATLAB and I didn't quite get it, right? That didn't really make things click. And things really flipped over for me, actually, when I started on Java. And there was this book by Alan Downey that actually is a professor at my school called How to Think Like a Computer Scientist. And I basically sat down, right? I just taught myself Java, and that's when I really felt like the world opened, when I really, really understood how powerful these programming languages were. First internship was in Java, and then I shifted, pretty hard from that over into Python. Now, I've got plenty of hobbies. I love Haskell, but I'd say 90% of what I do today is Python.
Python makes sense because it's simple. The language is a really powerful but simple language. So
I think powerful.
Libraries are just so nice to be able to grab somebody else's piece of work, add that library and add that library, sticky tape them together, and go, hey, it actually worked.
I have to say the thing I love most about Python is. I often say I think thinking about Python as a programming language is actually maybe not completely correct. What I say is the best Python is the least Python. Yeah. What Python is really, really good at least in my mind, right, is very good at connecting libraries built in very low-level languages, right? Those extremely, high-efficiency C and Fortran libraries, right? And then what I also really love about Python is the interface to it. It's so hackable. Right, any possible way you could dream of coding, right? Like, it doesn't matter whether you want, a functional coding. Like, I mean, when I found the AST module in Python, right, my immediate reaction is, this is a terrible idea. Like, I should not be allowed to modify the AST at runtime, right? That's too much power for me. But I just love that Python they kind of drop it all in your hands, right?
Yeah. I mean, even I'm probably a little bit newer than David. Newer, is that the right word? But back
younger.
I remember when I was on the because I used to probably came from Commodores and I was working with VIC-20s and Amigas and stuff like that. So I remember being able to. I remember running out of memory on writing something, and I actually had to hack the display characters so that I could build sprites.
Oh, really?
Because I needed more space to store.
I love that.
We don't need lowercase alphabet.
No, it's overrated. No, I have to say some of the you ever heard the story of Mel?
No.
This is, I think every. I mean, I'm not going to do it. Just everyone should kind of go and do this, right? Because I think that one of the things that's always been incredible to me, right? Especially, I'm a very, very fresh new programmer, right? And, you read back about all of the incredible things, especially in early video games, right? I think that's the place where you just see the most incredible stories. Like, what did they have to, distort to make Pac-Man work, right? And Mel is the very first one of these, is basically the story. And back in, like the 50s or 60s or something insane like that, he was in charge of building a poker game. It's like this 4-page long short story, right, about this entirely inscrutable thing. They had the memory in these big drums, right? And he would hack the memory location such that when it cycled over to the next instruction, he was making sure that the registers was, right on the other side of the revolution of the drum. Right, it's like just insane optimizations, and then they tried to fire him, and no one could get the thing to work.
Yeah, because we don't care, and these days we don't care about memory allocation or anything. It's just
speak for yourself, Michael. I have to say, AI is probably. I mean, I run it. Out of memory errors are still the most common error I run into. Yeah, but that's I'm rare in that case.
I don't know. I think hackers like memory overrun too. Memory and hacking. It's a very that's a good one.
Yeah, definitely.
How is it that it's 2021 and we still can't fix buffer overflows?
I know. Yeah.
Who knows, right? I guess once we find them, we can fix them. But
but you never find them because they never happen in test labs.
Of course not.
I love the one of a tester walks into a bar, orders a beer, orders 100 beers, orders -2 beers, orders Z beers. The first customer walks in, asks where the toilet is, and the bar blows up.
I love it. I absolutely love it. Look, I mean that's code in a nutshell right there.
Yeah. You've mentioned. I mean, we've been speaking about AI for a lot. What's the realm that you have the most interest in deep learning and AI and everything?
So for me, the thing that has always kind of captured my imagination more than anything is language, right? I'd say that was the core of Indico, right? And I think when I think about a lot of the most interesting and difficult challenges that were kind of pulling me in early in AI, they were all around that. My interest has expanded from that a bit, sort of in recent years, and maybe this isn't fair to say, but it feels like we've made really kind of incredible progress. And the transformer architectures, frankly, they've solved a lot of the problems in NLP that I was originally really excited about. But it's kind of unearthed this whole new world of really, really fascinating stuff. So, one, for instance, is this thing called multimodal AI. And so, either you heard of multimodal AI?
I have.
It's very... Oh, nice. Awesome. Yeah. It's very, very kind of new field. And the way that I explain to folks, think of drinking a cup of coffee, right? So you drink a cup of coffee and you don't even think about it, right? Very, very easy kind of, there you go, right? But a lot of systems have to come together for you to do that effectively, right? You got to know where your arm is. You have to be able to see the coffee. You have to sense the temperature, right? And you have to sip appropriately. It's actually a lot, there's a lot of complexity in just taking that sip of coffee. Now imagine, if you will, for a moment, if you tried to take a sip of coffee, not like you normally do, but as a purely visual problem, right? So imagine your arm is numb, right? You got no sense of temperature, right? You can't tell where your arm is physically. You have to see where it is, right? Every motion, you can't feel how far you moved. You have to, again, do that visual check. And you see how very quickly a trivially easy problem becomes impossibly difficult, right? And I think that in a lot of ways, this is actually the issue with AI today. Right, is that we have, and then it's very understandable, right? Because I think if you look back decades and decades, like vision was hard enough, right? Language was hard enough, right? And we had these grand challenges, glue and ImageNet and all that. But one of the things that's really, really incredible is that has changed a lot in the last couple of years, right? I mean, ImageNet, which was supposed to be this grand challenge that would, keep us busy for decades and decades and decades, years ago, right? They're like, we're too good at this. This is not a useful problem anymore, which is incredible. Right, and the same thing, right, has happened with glue, but it's asked again sort of these more interesting questions because on the one hand, right, we can exceed human performance on these tasks, right? We can get a better accuracy than a human, but at the same time, you put a 3-year-old in front of one of these machines and they'll trick it in 15 seconds. Right? Yeah. And so I think that this is one of the really interesting kind of core paradoxes of AI, right? And multimodal AI, I think it's one approach to solving that, right? And I come down to the classic example of huskies versus wolves, right? And so you're telling, is it a husky, is it a wolf? And you give it a bunch of images, and the computer, it's very, very accurate, far more accurate than any human ever, has been at this problem, because it doesn't look at the dog at all. It just looks at the background, and if the background is snow, it knows it's a wolf.
Right.
And then that asks some really interesting questions, right? Because the immediate reaction is, oh, it did it wrong, right? That's the wrong solution. But then you ask the more interesting second question, which is, why is that wrong?
Yeah.
What is it about that question that's wrong, and how do we fix
about
that?
Something. It's making an assumption, and humans do that as well, I think.
They do, right? And I think that one of the things that's really interesting is we have to be really conscious about the questions we're asking the AI, right? Because to us, wolf versus husky is this particular problem, right? But to the AI, the problem is termed in these sets of images, right? And it's even possible, right, that its heuristic of looking at the snow is probably way better than what I would do, right? But it's also, training? It's a fundamentally different problem.
Is that the training?
It absolutely is.
It's all about the training we give. So it's
all
looking
about
at the
training.
pictures and or the ones and the zeros that we provide it that it's looking at and giving an answer for.
Right. And I think one of the things that's really interesting, right, is that in the traditional computer vision world, it has no concept of what a wolf or a husky is. It doesn't know those are dogs, doesn't know those are anything. I mean, it might be 1 and 0 for all it knows. It could be snow and grass, right? It has no idea. So multimodal AI says, okay, let's fuse those. Right, we'll bring the linguistic understanding in. Right, we'll bring the visual understanding in. I mean, OpenAI has been really, really big splashes here. Clip, that's an absolutely awesome paper. Dolly, is an absolutely excellent one as well, where they've really kind of advanced it. And it's not going to fundamentally solve all of our problems, right? But a large number of very significant problems it gives us a very good beat on. And at Indico for us, right, we do this very much in the document space, so documents, that's text plus image, and they have to kind of interrelate in very non-trivial, pretty sophisticated ways.
You have to understand the words as well as the image to put context to the document. Yeah,
one thing we sometimes, it's a joke at Indico, we say tables don't exist. Because you think of a table, right? In a document, right? And you've got sort of your archetypical view of a table, and it's got individual column headers, individual row headers, and then you've got a value in each intersection. Now, I promise you, you've never seen a table like that in your life. It turns out no one ever makes that table. Right? That's never existed, right? Sometimes you've got rows, sometimes you've got nested columns, right? And it's one of these just like very, very fascinating things where we don't even think about it, right? Or you think about, nesting paragraphs in a legal contract, right? A human, you look at that and you just immediately understand what's happening. But to a computer, this is bafflingly complex, especially if you're trying to do it from a pure linguistic perspective. And it turns out it's difficult in both perspectives. You can try pure visual, you can try pure text, right? They both have problems, they both have very different problems, and then by combining the two, you hope that you can actually solve both those weaknesses.
Okay. So you just spoke then about Indigo with pictures and text and merging them and AI and blah, 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 blah. Okay.
Yeah.
Isn't that Google?
Well, I think it's very, very interesting. So when you look out at a lot of the major players here, right? So let's say Google and Facebook and OpenAI, Amazon maybe, I'm going to kind of loop them all into one group. I think that one thing that's very interesting is that they've all decided to tackle AI in a very, very particular way. And I think what's especially difficult is that what's interesting to end users and customers, right, is often very different than what is interesting to academics. Right. And one of the things that is also just so difficult, largely because deep learning, it's crazy to think about it now because deep learning is so insanely popular, right? But for decades and decades and decades, deep learning was so unpopular. In 2012, there were really only 3 labs in the world that studied it, right? Which is crazy. It's absolutely nuts to think about it. But it also means that when you look at today, there's very, very few experts in this space, right? I mean, if I had to estimate, the number of deep learning experts you've got worldwide, it's probably about 1,000. And that's a lot better than it was a couple of years ago. And when there's only 1,000 of these people, right, you don't have a lot of control to tell them what to do, right? And I think one thing that has been really, really difficult for Google is that, it's led to some tough culture aspects, right, on the one hand, but it also means that when you look out at the realms of AI that they're interested in, they're very, very different than what I'm interested in, for instance, right? I think OpenAI, they're at least working on multimodal stuff, which is interesting, and I think they're sort of toying around it. But, I think a counterexample to that, right, something that I'm intensely interested in is this notion of machine teaching, right? And have you all heard of machine teaching?
Yeah, I'm going to say yes, but I want to know from your context.
Yeah. So there was this awesome paper that it was Microsoft that put it out a couple years ago. And they basically said, okay, rather than thinking about the ML perspective, because very traditionally, right, in the academic perspective, you know, your mindset is, I get a data set and my job is to make the number go up. And that is it. Right? Like, period, end of story. And they're very, very good at that. They're insanely good at that. But it turns out that, you know, real life problems are a little bit more complicated than that. So machine teaching is this idea that rather than kind of assuming you've got this perfect interface of, you know, a pristine labeled CSV, right, that you just feed into your deep learning model, it's saying, nope, you know, toss that out the window, right? That's absolutely not where you're starting from. Start from the human being. Right? Think about what are the tools that they have in which, you know, with which they can teach the AI, and then you kind of back solve from there. And it turns out it's tremendously difficult because the supervision that people give, you know, when I teach you something, right? You know, teach a kid something, you don't classify stuff. Right? That's just not how you do it. Or, you know, maybe you do that with a couple of things. You know, this is red, this is blue, this is green. But, you know, that's 1% of the training you're doing. And so much of what they're doing, right, it's looking at the world around them, right? It's hearing, okay, you know, when you have something red, then this is the conclusion, right? You know, these much more complex instructions, right? It's fundamentally different kinds of supervision and training than what we're used to. But sort of similarly, and you know, it intersects with multimodal AI, you know, pretty heavily, because similarly, we don't have ways of providing supervision for these kind of complex data sources today. So I think it's very, very interesting. You know, I would really, really love to see more of the big companies devoting resources to it. But, you know, I think the flip side, right, is also, if you're Google, you really care about optimizing your advertising business, right? Yeah, and look, 1% incremental, you know, improvement on your advertising business, you know, that's billions of dollars, right? Yeah. So that's fine. You know, you focus on that, and they don't even have to work on the rest of it. But, you know, what they have done that's really wonderful, and that I love about the ML space and AI in general, is that all of their research is public, right? You know, basically, you know, a few years back, and ML could certainly be better, but they're far better than any other field here, right? You get something like 50% of papers are coming out with code, right? Which is, like, you don't see that in any other field. You know, and I'd love if it were 100%, but still, you know, I think it's really, really positive. So I think that, especially for small companies that are trying to go and, you know, compete against Google, for instance, you get to leverage the incredible research engines of, you know, Google and Microsoft and OpenAI. Again, all that stuff is public. But what they're also doing, and this is sort of how research works, right? It's every advance you make, you open up more surface area, right? Like every question you answer, it almost brings up two questions, right? And I think that's what really lets startups make interesting progress in this space, right? Even though you've got Google throwing billions and billions of dollars at it.
Yeah, you're not restricted either. So because you can go off onto different tangents and not worry about whether the shareholders are going to start going, hang on a minute, that we're spending too much money on that.
Yeah, and you know, like I can go and talk to the product people next to me, right? And the product people can talk to me. I think when you look at these big companies, right, the difficulty is just how heavily siloed they are. Right. And you know, I think especially when you start talking about machine teaching and multimodal AI, right, they're fundamentally these interdisciplinary approaches. And AI is obviously critical, but user experience is critical, right? And product design is critical, right? And the pure software engineering is critical. It's kind of like, you know, GPT-3. The joke is that, you know, the delta between, you know, GPT-1 and GPT-2 and GPT-3, there's basically no ML change there, right? It's purely software engineering and scaling the thing up. Which is, on the one hand, it's interesting in both ways, right? I think that academics can get a little upset about that, but at the same time, I think it just underscores how important it is to really work in a collaborative way here, and that's just harder for big companies.
Yeah.
So what makes Indico stand out in your, like, we all know AI and machine learning is a niche product, a niche area at the moment. You know, when I did a bit of work when I was learning my autonomous vehicle communications, they looked at my code and they said, that's really interesting code. You know, I pulled all the libraries together. Yes, that wasn't a very good answer. I made the vehicle work, but it was interesting code. But what makes Indico stand out so in a niche?
Yeah, I mean, so the specific area we play, right, is this area of intelligent document processing. And it's one of these things that's really tough because it's such a massive market, right? And there's so many companies like trying, especially, you know, like if you look at AI in general, right? Is that, again, it's on the one hand from a technical like skills perspective, it's a very, very niche area. But I think the thing that's interesting is that while deep learning is this extremely rarefied niche, from a market perspective, deep learning doesn't actually get segmented out from the rest of machine learning, right? And so in the intelligent document processing space, for instance, and this is, I mean, honestly, it's embarrassing to me, like 90% of what people are selling is like static templates. They're like XY bounding boxes, right? And so, you know, for forms that are entirely static, right, they work perfectly. They don't use deep learning, you know, maybe in, you know, like a very particular, like narrow area, right? You know, they probably use a very broad sweeping definition of deep learning. So, you know, the differentiation just between us and call it 95% of the rest of the market, right, is that you don't need templates, right? We actually are using modern techniques. What's really critical in modern techniques is transfer learning. So most folks, the way that they attack these problems is that they, you know, have a bunch of data scientists in a room. They build something totally bespoke for one use case, right? They ship it as this sort of static black box API, right? And, you know, like this is a, you know, read OCR, right? You know, like, oh, this is like how so many offerings kind of appear. And we actually take a fundamentally different approach. The reason people traditionally do that is because you need so much training data to make one of these deep learning models is that it's intractable, right? You know, if I want to process invoices and I need 1 million invoices to train my really awesome deep learning model, that's never going to happen, right? You know, and especially when you're starting to talk about documents like contracts, right? It's not even a question of whether you can get access to that data. That, you know, there may not be 1 million distinct NDAs in the world, right? And so transfer learning, we made a really, really big bet on very early in our history, right? This idea that we want to reuse portions of old network models, right? And sort of the art and science of doing that to solve new problems more quickly. And so our product, rather than, again, sort of shipping these static black boxy type things, it allows our customers to actually create their own models, right? You know, they don't have to, you know, deal with some massive data science team on our back end. So that allows us to really do a lot different from the product perspective. You know, we always say you can build your own, you know, production quality model with 200 examples. I mean, you know, y'all from the ML space, you probably know how tough that is, you know, how small that number is. But, you know, so that's the key. You know, this multimodal AI stuff, you know, we have also been integrating into the product really, really heavily. And you know, that's another pretty sizable differentiation for us. Yeah. So those are really our main focuses, I would say. Awesome. You know, we're making really good progress in machine teaching, but I mean, it's just a brutally difficult field. You know, so ask me again in a year and maybe we can claim that one too.
I wish I'd asked you a year ago.
That's fair. You know, it'd probably be very different.
It would. It'd be really interesting stories to sell.
Oh, you know, yeah.
Yeah, it's incredible. Hey, Slater, you mentioned that, you know, there's probably only 1,000 deep learning experts in this field. Do you think that there's that there's a way to get more people involved and in doing that be more inclusive of people?
I mean, so I certainly hope so, right? You know, I think that, and this is both true in deep learning, right? And I'd say sort of broadly across tech. I think tech's got this problem, right? And I think every single person in my spot, right, on the hiring side has had this issue, is that we've got massive talent gaps, right? Everywhere you look, right? It doesn't matter whether you're looking at DevOps or, you know, like data analyst, right? Data scientist, deep learning, right? Every single place, massive talent gaps.
Cats.
Cats, massive talent cats.
Massive talent cats. Look at these
and what I feel like,
we'll cut that bit. It's okay.
Oh, no worries. So what I always feel like, right, and what always kind of bums me out is that it feels like when I look out across the talent pool, you know, and these are folks in their 30s and 40s, you know, have, you know, dozen years of experience, I feel like so many decisions were made for me in their, you know, K through 12 and college experience, and I feel like, you know, 50% or more of the people that I should be looking at are just, you know, I can't, you know, they're just not in this field, which is super unfortunate. And, you know, I don't know what it's like over where you are, but in the US, it is crazy to me that in your entire K through 12 education before you get to university, there's not a single computer requirement anywhere, right? Insane. Wow. In 2021, right?
Yeah.
I think that, certainly by the time you get to university, every person should have had at least one, like technical class, learn to code a little bit. Not everyone's got to be a programmer, but just understanding a little bit there, it does you so much good for life. So, look, in terms of making tech more inclusive, I think that there's a couple of things. So, absolutely, we have to hold companies to account. I think, Google made this announcement recently with their mentorship program, but frankly, after what they did to Timnit, like, you just can't play from behind like that, right? Mm-hmm. I think that Jeff Dean, I'm sure his heart is at least tangentially in the right place. I've had a lot of respect for him over the years, but it is a bad look, right? You look at folks like, Joy Buolamwini, right, and Timnit Gebru, right? I think they're doing really incredible work in making it clear what the potential for harm in AI is, right? Yeah. I think it's very, very important work, and I'm so glad that they're out there blazing trails. But there's very, very few of them, right? And the couple of folks out there, right, that are really that have gotten to the other side and actually succeeded, right, with all the odds against them. It's actually, unfortunately, they haven't even succeeded, right? Because they still face all this backlash, right? Getting kicked out by Google and all that nonsense. So I think that it's very important for companies on the later side of that journey for individuals, right? To be clear that, like, look, this is an important priority, right? And we're actually going to adopt this ethically and responsibly. Because I think something that people really, really don't understand about AI is, and I think this is probably one of the most sort of harmful notions out there, and I think it really discourages folks from non-traditional backgrounds coming into this space. We have this notion of AI as this infinitely objective arbiter of truth, right? Mm-hmm. And that is absolutely the wrong way to think about it, right? We're brought up on science fiction and all that, right? But the way that I like to talk about AI is it's more like a mirror, right? But it's not a perfect mirror, right? It's a mirror and it's got sort of pock marks all over it. Yeah. And so the problem is that you take everything that you've done and you sort of shine it at this AI model, and it's got all these pockmarks, right? So you don't have a lot of control. Random bits it's going to eliminate, or it'll decide, this thing is really, really important. So it's, it's a little bit lossy, right? But it is fundamentally a mirror at its heart. And so you look at the Amazon resume reviewer, right? I think this is, I absolutely have to put them on blast for it, right? Mm-hmm. They put this resume reviewer out, and immediately they basically figured out this thing is horribly sexist, right? And I don't know, Smith College is a school, out near where I go, incredibly top tier school. And for one random quirk of this is that if you went to Smith, it wouldn't even look at the rest of your resume; you were just rejected. And this is one of the top schools in the country, right? Which it's like egregious, and there's a dozen other like little quirks like that hidden in it. And what they did is they put a team of PhDs on it for a year, and they said, figure out how to solve this. And they approached it as an AI problem, right? So they said, like, tweak the model, change the model somehow to make it not biased. And what their conclusion was at the end of the year? This is impossible.
This is impossible.
And the reason is, fundamentally, the answer is this is not an AI problem. Right? You can't make this an AI problem. What's happening here is that we are reflecting what Amazon has been doing for its history, right? And really, what I say, right? And then after the year, right? Year and a half or whatever it was, Amazon's like, all right, this is impossible, so we're shutting it down. We're going back to the old process. But to me, what I hear when they say that is, we shifted over to a process where our bias was measured and held in front of our face. Right. And that was uncomfortable. So we're going back to the old way where it's not measured, right? Where we don't have that transparency.
Instead of taking the challenge and maybe being more predictive about things and using other sets of data that may not be in their control.
Yeah, absolutely, right? I think it's really, really tough, right? I think that the thing that people are not willing to do is say, hey, we have to actually set a goal for what an unbiased system looks like here. Yeah. Right. And look, and that's a hard problem, right? And I don't want to say that, that's super easy. Just make everything balanced. No, like, absolutely not. Right. There's real difficult discussions that have to happen to figure out what that looks like, but they have to happen. right? And to me, you see all of these places, right? And Amazon, they're just a public example, right? But this is happening, versions of this everywhere.
Just look
right?
at facial recognition. The early facial recognition was so
Yeah.
biased to a white man and racist and sexist, and even now some of the cheaper facial recognition systems are still based on that original one, where if you're a colored person, there's no face.
Well, I mean, Joy Buolamwini, her story back in Coded AI, she had that white, theater mask that she had to wear so that she could be recognized, right? Yep. And you know what the worst part of it was? So I actually had the pleasure of meeting her, back when she was at the Media Lab. Everyone knew. Every single person, every single AI professional knew that any facial recognition system they shipped would be biased. I said it publicly, right? No one was surprised. But the thing is, nobody did anything about it. No one saw it as a solvable problem. And what was even worse, right? And this is actually where I went from this is a problem to solve to this is an existential ethical crisis, is that they started selling it to law enforcement.
Okay.
Right? And it's that this is biased, right? And I think that's where things get really, really tough. So I'm not a big fan of direct AI decisioning, right? I think that's a bad idea. I am a huge fan of sort of human AI collaboration. I think that is the right way of approaching things, and we just have to think of it holistically, right? They're not black boxes. They're just not.
And as you just said, everybody knows that everybody knew that AI was biased, but that was only everybody on the inside. Nobody knew it was biased on the outside. So you've got this small niche of people who knew it wasn't going to operate as they wanted it to, but on the outside, everyone thought it was the dream machine.
Exactly. And it's unfortunate, right? Because you still see that, and this is the problem that I think is really tough to solve, right? Is I think that there has to be a lot more AI literacy out there, as adoption accelerates, right? These areas of impact, I mean, they're increasing, they're not decreasing, right? I mean, I think there's Cassie Kozyrkov, and she's another sort of thought leader in this space I absolutely love. She has this meme that she posts, which is, it's like machine learning, do stupid things faster with more energy. And that's exactly what it can be, right? If you're not careful.
I mean, buzzwords come to mind. We've always been through the buzzword trend of all sorts of things. And I get so, I don't know, it does make me a little bit angry when people just go, oh, we'll just use some AI on that. And it's like, in what way? How?
But what do you mean?
Yeah, or this we're going to develop this app and it's got AI in it. Okay.
And it does what? No, we always joke about the scrape the internet and do magic use case, right? So, and this is something that customers come to us with all the time, right? Someone said, "Can you just go out there?" And they'll usually use those words, scrape the internet, and tell us which companies are about to buy which other companies. I'm like, okay, and what makes you think this is possible? Yeah. Like, well, I mean, it's AI, right?
I'll do that as soon as I've rebooted the internet.
yeah, exactly. Well, we've got to reset it first, you see. And then we've got to, I think, it's just, I think a lot of people see AI as a genie in the bottle, right? Yeah. I think especially when folks talk about, even the old school AI stuff, right? Like the Turing test and whatnot. I have a friend who, he loves the Turing test. And he's like, well, yeah, I want an AI that's going to tell us how to solve global warming. And I say, it's not AI's problem. It is our problem. We have to solve it. We could use AI as a tool to solve it. Sure, maybe.
Actually, I'd be really worried. I'd be really worried about what AI would say if it said solve AI global warming. Because
how do you even?
And you and I wouldn't be talking.
It was at Age of Ultron, right?
Yes.
That's right.
Yeah, and it's just it's like, how do you? And I think that fundamentally, I think it's just people have this view of AI as sort of this android, right? That's going to come in and sit next to them and they talk. And I just think that we've seen. And look, in the 60s and 70s, they didn't know any better. And, they can use those analogies and, they're all through sci-fi. I don't begrudge them at all for that, right? But we know enough today. That's not what AI is. It's not how it works. The way that I really like to talk about it, we like to talk about it in Indico, is it's a bionic arm. And it's maybe a little sci-fi for my tastes, but it's that idea that this is, like the steam engine, right? This is the fourth industrial revolution, right? Yes. It's helping us do the things that we're doing today more effectively. right? But it's still fundamentally humans that are in control of this. And just because we call it AI doesn't mean anything about it has changed. It's still software, right? We still have to control it and monitor it and test it the way that we do with regular software. But apparently that's a radical idea that we should test these systems before we put them into production. I hope we'll get better at it. But, I think that, when you look at the analogies today, it is sort of like software back in the 60s and 70s. And people are doing incredible work, incredible leaps of insight. But at the same time, stuff is incredibly unreliable, right? And folks don't understand what they're shipping, right? And I think that's a fundamental problem. And I think that's another really dirty secret, right? People talk about, desperate impacts, right? They talk about, bias in these models, right? And the ugly truth is that for 99% of what people are shipping into production, they can't even test these. They don't know if it's biased or not.
No, because we haven't written test frameworks for it completely.
Right. We don't have the data for it.
We'd need more data to test than we have to build.
Yeah, absolutely, right? I mean, we'd need someone who's actually willing to draw a line in the sand and say, at least for this use case, this is something that's reasonably unbiased, right? Or, come to some agreement, like what does a fair test look like for this? And again, I get that folks aren't willing to do it, and it's a sensitive subject, and sure, it's going to take us a while to figure it out, and that's okay. But then just don't ship AI into those applications, right? We've got to get that figured out first.
Yeah.
Slater, I've been working a lot with swarm drones and playing around with AI and connectivity of swarm drones recently. What is the most out there use of AI that you've seen?
Do you want me to be optimistic or pessimistic about it?
I want one of both.
All right. Okay, that's fair. So
David wants everything.
I want everything.
Okay. So I'll start with I think the biggest nearest term existential threat of AI that I just have no idea how we solve it, right? Because encoded bias, that is a big problem, but at least it is something that we can measure. There's theoretically a way to solve and resolve that. That is not true for massive misinformation campaigns, right? And I think that synthetic data and generative techniques, right? I mentioned it earlier, right? But so Alec Radford was sort of the original co-founder from Indico, and for listeners, he's the lead author on GPT-1 and 2. So he's pretty up here. So a lot of my thoughts here I do shamelessly steal from him. But the problem is that it is very, very easy to trick people, right? I think that certainly in the U.S., right, the problem with misinformation, right, and fake news and the Russian IRA, it is a really tangible problem today. And what people may also not realize is that actually these generative techniques are already being used by state agents. So, for instance, the Hunter Biden laptop, that was passed off by some, mysterious professor and it was analyzed. The whole thing was fake, right? The face was generated by DC GAN, right, which was an Indico project. So I honestly, I even feel responsible for it a little bit, right? I never imagined in a million years it would be used that way. But people are creating these fake personas, these fake profiles. They're creating these fake blog articles. And I think one of the most damning pieces of information here is when you look at OpenAI, right? And they actually did these experiments as they went from GPT-1 to 2 to 3. And the question they had was, these are powerful models, and is there a way for us to distribute these safely? That was the question. And they did, they came out with a lot of really cool techniques. So you can do model fingerprinting. So, you give them a static copy of the model, and then you can actually recognize predictions that specific model made downstream. So a lot of cool stuff. But you look at what they did with GPT-3. They did not give it out. They locked it behind an API, and I think in so many ways that was OpenAI saying, we do not know how to prevent abuse.
Yeah.
We can't do it. And I think the thing that's... today we're slightly saved by the fact that these things are extremely difficult to make. But...
it's not going to stay that way.
No, it's not, right? And fundamentally... They are things of the scale that state actors do have to get involved to make these things, right? A single training run here, it's $1 million in compute. It's tens of millions of dollars in hardware, right? For a single training run, right? You still got to develop the darn thing. And what I am worried about is that there's not a really convincing way to determine what's automatically generated and what isn't, right? These things have gotten very, very convincing, and certainly they're not perfect, but they're good enough that even a sort of comparably effective GPT model, right, to whatever generated it with, it can't really tell the difference. And I have no idea what the solution is, frankly, right? And I think that it's not that it's going to create that problem. It's taking a problem, though, that is already, in my mind, very acute, and I think it's going to make it 10 times worse. And I have no idea how we're going to solve it. So, on the more optimistic side.
Let's go to the other side now.
Yeah. So I think one that was really, really cool is that people are using AI to stop poachers, which I thought was awesome, right?
I did read about this. This is amazing.
Yeah, and the first I heard, I'm like, what are you talking about? Like, how is that even possible, right? I think there's a lot of really interesting things, especially at the intersection of sort of like satellite imagery and being like, hey, like a car just showed up here, right? And I think that that was a really, really great application that I loved. I think the other things that I think is just an awesome like area of opportunity is the potential for creativity, creative empowerment, right? I think that you see like a couple of these things where, you can doodle a little thing and, it'll turn it into, a photorealistic version of it, right? Or things like that, neural style transfer, right? I just think that, and Adobe has, they've done a good job bringing a lot of this into the Creative Suite, but I go absolutely gaga for, the combination of creative pursuits and AI. I think that that's a really, really potent, peanut butter and jelly situation.
Yeah, so over the last 6 months, I've been working on a project that uses a lot of the music AI generation tools.
Very cool.
So I bring stuff in from these tools, and some of it comes out very crazy and weird. But when you start working with other musicians on this, and you bring it all together, it actually turns into something real. So it's like you said about the bionic arm before. It is a tool to help you achieve a goal, and in some cases, I'm working in technology all day. I have no desire to come home and be creative. If I'm lucky, I come home and get an hour to spend on music, which is fantastic for me. But
yeah,
in those moments when I'm not feeling creative and I don't want to just pluck a tune out of the air, it's actually nice to sit back and go, hey, you know what? This might provide some inspiration to do something.
Totally. And, I think what's really cool is seeing all of the kind of back and forth you can empower, right? Stuff where, like maybe you're feeling creative one day, but you don't want to do like the detail work, right? Yeah. Maybe AI can help that way, right? Maybe you just want to see like, give me 10 like crazy melodies, right? Yeah. Just like get my mind, get my juices flowing.
Yeah. So yeah, I that I agree with you on the creative side of things. That is going to make the people who are doing this creative work, whether it's art or music or anything creative, really, it's going to give them the inspiration and the tools to actually deliver what they can see in their head out to, their finished works.
You see,
that's absolutely what I'm hoping.
Listening to you guys with music and art, I'm just looking at AI as how's malicious code been inserted into, and I'm thinking, this is boring. I want to play with music and art.
I'm like halfway through rereading 2001, actually. So thank you for that. Yeah, I mean, it's just great. I feel like every couple of years you just have to go through it.
Yeah, and there's other novels I love. I don't know if I can't remember the name of the author at the moment. Ian M. Baxter, I think. Anyway, he does a series of books about this race called the Culture, and they've got
yes, Banks. Ian Banks?
N.L. Banks.
Yes, yes, the culture ships.
They've got these culture ships are like all AI. They're sentient ships.
Yeah, but they're also very moody and they've got their own personalities. And sorry, there's
science fiction stuff that I'm really into. It's crazy.
I think that world is absolutely incredible. I mean, there's not a lot of. I'm trying to think of anyone else that's like done a post-scarcity world at like that level of technical sophistication and done it that well. But
so detailed.
Okay. Yeah, I mean, I've only read kind of snippets, but that's like high up on my list.
You're actually into martial arts as well.
I am.
I'd like to know more about that.
I have to say, because my partner's upstairs and I'm with her in-laws, and they're, real kind of heavy Taekwondo folks. So I haven't done it in a few years, so I'm a bit rusty. She's a third degree black belt. I've got a couple of black belts. I think that, so, from, I don't know, 3 or 4 or something. Like, I was very, very young when I started, right? And then I think the summit for me, I did a few, amateur MMA matches, and then I studied martial arts in China, for a few months, in like a very, very kind of dedicated way. And I mean, so I love martial arts first and foremost, right? So I did a lot of Japanese martial arts, karate and aikido. That was a lot of where I started. I did a little bit of taekwondo, hwarangdo, which is Korean martial arts, but different than taekwondo, and then Chinese martial arts, obviously in China. And I was doing xingyi there, which probably no one has ever heard of, but it's sort of halfway between tai chi and boxing, if you can imagine such a thing. And what I think is that, so there's 2 things about martial arts that I think really have served me well in technology. One is just pure grit, right? I think one of the things that folks can miss is that so much of just being a good programmer, right, it's the work, right? You just have to, pick yourself up, right? And, if you... Maybe, it's 4 a.m, the project is due at 9, right? You just got a seg fault and you have no idea what's going on in your code, right? And that grit to say, okay, I've still got to pick myself up and try again, right? Yeah. In Chinese martial arts in particular, they're actually very, very different from most martial arts. So in xingyi, for instance, so the entire martial art is 17 moves. That's all of it, 100%. And the first 5 years is 5 moves. Right? Which is crazy, right? So, but what you're doing is you're just perfecting it, and you're doing it back and forth and back and forth and back and forth, thousands and thousands and thousands, tens of thousands, hundreds of thousands of times if you actually get, better than I was. And that kind of single-minded focus, right, on really getting something to work, that has really, really served me well. And I would say the second one is just getting hit in the face.
I'm being able to stand up again.
Yeah, I think that it's something that tech folks I found in particular, for me, I like grew up with it, and, like my partner, she grew up with it, and so, getting hit in the face, it's just normal, right? Yeah. Tech folks I've learned, they don't like getting hit in the face, they're really scared of it. And I think there's really something to just saying, like, look, getting hit in the face is scary, but it's not bad once it's happened. Right?
Yeah.
And I think there's really something to that, right? Just that idea that, like, you're going to go through really, and maybe this is more entrepreneurship than the tech side in particular, but just you're going to get hit in the face, you're going to go down to the mat, you're going to lose a couple of rounds, right? You're going to screw up, you're going to get injured, right? And you got to keep going.
Yeah, you've got to get up and get back on that horse.
Absolutely.
So around you at the moment, you've got all this AI work going on, you've got information coming in. What's your favorite bit of tech?
Broadly, today or in the future?
No, right now around you. What is your, I love this bit of tech, my mobile phone, my robotic vacuum cleaner, what's your favorite bit of tech around
Goodness. You? God, that's such a great, so, okay, I'm gonna have to go sideways on this because, contrary to popular belief, I'm a dinosaur. Mm-hmm. I'm a total dinosaur, and I would have to say that my favorite piece of technology is paper.
Mm.
Oh,
so I have to say this is like, and
I
this is
just like to show you this stack of index cards that I keep.
Yes,
that's my technology. So.
No, it's the funniest thing in the world. I have to say. So investors, they have summits from time to time, right? Mm. So you go to the product person summit. You go to the CEO summit, and I used to be the CEO of Indico, so I used to go to all of these, right? And you see a lot of people taking notes on computers, right? And maybe there's a little bit of variation. But the thing that's surprising is if you go to the CTO summit, every single person takes notes on paper. Every single one, never seen an exception to it in all the years I've been doing this, right? And I think that what's so incredible is that, and the pandemic has made this so clear, is that as much progress as we have made in technology, we cannot replicate paper and pen. Mm. The simplest thing in the world, right? We've had it for thousands of years, and we just can't do it, right? I mean, there's no, like, have you ever had a technical experience that got anywhere close to the experience of pen on paper?
No, I've got a tablet that I use with
Me too.
and I don't use it. I had a, one of those paper-like tablets.
I wanted to try one of those.
Tried that out for about 3 weeks from a friend, and I didn't like it because it's the feeling of it's the textile feeling of being able to grab a page and move it and flip back through the book to find out where your last note was about something.
Absolutely, and it's just being able to do these free-form drawings, right? I mean, like, just getting together with folks and even collaborating. And whiteboard, I'll consider like maybe that's basically the same thing, right? But I don't know. There's something very, very special about it. And
those drawings don't always make sense.
I mean,
the future. They make sense at the time, but in the future, you look back at it and go, "What the hell?"
No, I mean, there's like this time element to it almost, right? It's not just that. It's like how you drew it. It's like, there's 10 boxes with, 6 letters strewn about them, right? And you look at it at the end, nothing makes sense. But it's like the way in which you progress.
To that point, yeah, that's a really good answer. I love it. I love that answer. And I'm working in a business at the moment, and I haven't printed anything for 4 months.
I will say I don't print things. Yeah, I don't print things at all. But it's just I've got like a bookshelf case full of notebooks. Yeah. And I have to say the most fun you ever have, right, is finding a notebook from, a decade ago, flipping through it, being like, what was I doing? Right. Yeah. What was going through my head then?
I loved looking at the doodles I used to do.
Yeah.
At the top of the page.
I used to be good at that.
Yeah. I found one where I wrote this page is intentionally left blank. I don't know why I wrote that.
So you were doing a lot of testing, I bet.
On the other side of the page, on the other side of the book, there was obviously something really important, and I didn't want to disturb it with some other notes. So,
I see. I remember once upon a time, I wrote a note that said, "Thank you so much for trying your very best to make the world a better place." And I found it, 5 years later. I completely forgotten that I had written it, but I was just like, wow, that was exactly what I needed.
It's not nice. It's a beautiful thing to find, isn't it? A note to your future self.
Exactly. Gotta be kind to yourself.
Slater, we've got 3 questions that we ask everyone to keep things consistent because we always seem to go off track, and we're not saying we have today, but we've.
That's half the
fun. What would you do differently if you had a chance?
So, look, I would do so many things differently that I almost would say that I can't do anything differently, if you follow, right? So I would say that I would tell myself, if I had to tell myself one thing, and it's not so much something that I would do differently, I would just tell myself that it is so much harder than you think it's going to be, right? And I would say, no matter how hard you think it is, it's going to be so much harder than that, and stick with it, right? I think that when I look at the regrets, there are times when I flinched, right? There are times when I didn't realize that real work takes time, right? I tell myself to be more patient and, swallow the pain, at least for bits at a time.
You don't strike me as the kind of person who would flinch. It really makes... It happens. It really makes because I think we all do. We all find those little bits of hesitation where we go, "Oh, this is more than I expected," and yeah, you're right. You have to push through it, but every now and then it's like, I just don't have the energy to do that.
Yeah, I think the biggest problem for me also is just when you're starting out and you're doing something on your own, you got a really big desire to just listen to folks that have a lot of experience and pedigrees and credentials, and I did a lot of that, and I did too much of that, frankly. Okay. Right. And I think the thing, especially for, young entrepreneurs and young tech folks, right, is that the world is a massive place and no one is an expert in what you're doing. Yeah. Right. Yeah. And recognize that you can get advice and people can help and you absolutely should talk to them, but they don't know it as well as you do.
Yeah.
No, it's like a hard thing to recognize, but it's important to keep in mind.
Yeah. If you weren't doing what you're doing now, which is a lot of things, what do you think you would be doing?
So, what I'm doing with my free time that I'd probably be doing a lot more if I could is I'm writing science fiction novels.
Oh, wow.
I love it. I have to say. It scratches an itch that I didn't realize I was missing.
Have you had anything published yet, or?
I've got one book out there published.
Under your name, or do you have a...
Yeah, under my name. It's on Wattpad. You can check it out. It's not popular, but it exists.
It might be after this.
I mean, I will say it's not kid friendly. It's it's an adult science fiction book. It's also not great.
we're not a kid friendly podcast. It's all right.
Okay, perfect. Yeah, no, I mean, I'd be doing a lot more of that though. I think if I had the spare time.
Yeah, that's great.
And what's it called?
The Bloodless.
The Bloodless.
Wow, that's nice.
Yeah, I call it.
That up.
It's a pandemic fan fiction.
Perfect.
Yeah.
Now you're probably very uniquely placed to answer this, but do you have any predictions for the future of your industry?
What time scale do you want?
Wow.
50 years.
Yeah, 50
years.
Yeah. What are we looking at in 2070?
2070. So I think when we look at AI in particular, I think 50 years out is probably far enough that quantum computing is going to be a reality. Mm-hmm. I'll probably first start by saying that I think 50 years is too far for me to know. My hope is that
5 years is tough to predict, isn't it?
Right. I was like 5 to 10 years. I think that I can do. Right. 5 to 10 years. I think that we see a really massive explosion in these multimodal AI pieces. I think that there's going to be some really embarrassing issues in the next 5 to 10 years. Right. I think that's my number one piece. I think that maybe in 50 years, when we're looking back at today, maybe more than that, right? I think that we're going to be really shocked at how crude our approaches to AI were and how poorly monitored they were. I think that in just a complete tangent, but because we're at the end, I think one other technology I'm very, very excited about is self-assembly and nanotech. And a lot of people don't realize this, but one of the core limitations of technology today is magnetic density. Right. So, like those rare earth magnets. But when you look at motors, right, computers, hard disks, like pretty much everything, it is bound by magnets. And this is sort of the one technology that we think can maybe get us to the other side. So, I think quantum computing, self-assembly for next generation magnets, right? I think that maybe with those two together, you'll get a real immersive haptic VR experience, right? Maybe we'll have that in 50 years.
Maybe in 50 years.
Maybe.
I like the nano computing idea. That's interesting.
Assembly,
yeah. I mean, I've got friends on that, but they say 50 years might be fast, but I'll keep my fingers crossed.
There was a whole Stargate
episode, the series.
Not episode. It was like it was nearly a whole series based on the nanotechnology type.
Oh,
of
really?
Yeah.
I'm sure it was a lot of fun.
Yeah, I don't know.
Yeah, I'm embarrassed. I haven't actually seen Stargate. That's got to be one of the big classics.
15, 20 years ago. So it was. It's not fresh in my memory at all. So
I've heard it's one of the best series out there. So I mean, it's another one on my list.
Yeah, there's too much to watch, too much to read.
Yeah.
All right. It's been really wonderful. It was so interesting to talk to you. I'm really happy that we made this call today. And thank you very much for your time.
Absolutely tons of fun. Thanks for having me.
It's been really good fun. I love talking tech. I love talking AI.
Yeah, I mean, look, it's a fun space to be in, and it's a really fun time to be there.
Thank you very, very much.